Hello students, so moving ahead with the last lecture where I was discussing about the 8086 microprocessor minimum mode pins. So I discussed about WR bar, I discussed about HOLD and HLDA pin. The next pin is M/IO bar. So it is used to distinguish memory data transfer whenever M/IO bar pin is high. And input output data transfer whenever M/IO bar is low. So again I am repeating, whenever M/IO bar is low, it means input output data transfer is taking place, and whenever M/IO bar is high, it means memory data transfer is being taken place. So again it is the output pin. It means microprocessor is outputting the status, what type of data transfer is being taken place, or whenever what happens whenever microprocessor sends any address. 8086 microprocessor sends any address through the address bus, immediately it also activates the M/IO bar pin. Either it makes it low or it makes it high to tell the memory or input output device that the address which the microprocessor has sent through the address bus is for memory or for input output device, or the data bus is memory or input output device. So at that time microprocessor activates or uses the M/IO bar pin. The next pin is DT by R bar. This signal is used to control data flow direction. High on this pin indicates that 8086 is transmitting the data, and a low on this pin indicates that 8086 microprocessor is receiving the data. Next pin is DEN bar. So this signal informs the transmitter as well as receiver that CPU is ready to send or receive data. So whenever this is activated means CPU is ready to send or receive data, and it is to inform the transmitter or receivers. Next pin is ALE. This signal is provided by 8086 microprocessor to demultiplex the AD0 to AD15 lines into A0 to A15 and D0 to D15 using external latches. The next pin is INTA bar. This indicates recognition of an interrupt request. It consists of two negative going pulses in two consecutive bus cycles. The first pulse informs the interface that its request has been recognized, and upon receipt of the second pulse, the interface is to send the interrupt type to the microprocessor over the data bus. So this was all about minimum mode pins. Now maximum mode pins. These are the maximum mode signals, that is QS1, QS0, S0 bar 1, S1 bar, S0 bar, S1 bar, S2 bar, log bar, RQ bar slash GT1 bar, RQ bar slash GT0 bar, GND. So GND is representing the ground. Okay, one mistake I have done here. So GND should not be here. 33 pin is not for GND. Can I rectify it? It is not for GND. 33 pin is for MN/MX bar. Okay. So the first pin that I am going to discuss under this maximum mode is RQ bar slash GT0 bar or RQ bar slash GT1 bar, that is pin number 30 and 31. So it is an input output type pin, means RQ bar is the input pin and GT0 bar is the output pin. So in the maximum mode, hold and HLDA pins are replaced by RQ bar, that is bus request, or GT0 bar, that is bus grant, and RQ bar or GT1 bar signals. So as I've told you, when I was discussing about the minimum mode pins, I discussed about hold and HLDA pins. The same function is being played by RQ bar and GT bar pins in the maximum mode, the same function. So by using bus request signal, means RQ bar signal, another master can request for the system bus, and microprocessor communicate that request is granted to the requesting master by using the bus grant signal, that is GT bar signal. So both the signals are similar, except RQ bar slash GT bar 0 has higher priority than RQ bar slash GT1 bar. Means this is going to have higher priority than this one. If both the RQ bar, both this pin and this pin gets activated, this will be having the higher priority and going to get served first. So now next pin is LOCK bar, lock bar. So this signal indicates that an instruction with a lock prefix is being executed and the bus is not to be used by another processor. Next pin is QS1, QS0. So these two output signals reflect the status of instruction queue. I told you when I was discussing about the 8086 microprocessor architecture, I told you there is an instruction queue in the bus interface unit, and that instruction queue is of 6 bytes. So each location is having 1 byte. Each location can store 1 byte. So if the opcode is 16 bits, if the opcode of the instruction is 16 bits, so it will get stored in 2 consecutive memory locations. So what happens, this QS0 or QS1, these output signals reflect the status of instruction queue. This status indicates the activity in the queue during the previous clock cycle. So as you can see, the if QS0 is 0 and QS1 is also, if both the QS0 and QS1 are 0, means no operation is being taken place, means the instruction queue is at idle state. If QS0 is 1 and QS1 is 0, it means first byte of opcode from the instruction queue is being fetched. If QS1 is 1 and QS0 is 0, it means the instruction queue is empty. If both the QS1 and QS0 are 1, 1 means the subsequent byte of that opcode is being fetched from the instruction queue. And the last pins are S0 bar, S1 bar and S2 bar. So these are connected to bus controller. These 3 status signals indicate the type of transfer to be taking place during the current bus cycle, which means if S0 bar, S1 bar, if S0 bar, S1 bar and S2 bar, all the 3 are 0, means interrupt acknowledge machine cycle is being taken place. So it will tell you the status of S0. In short, the status of S0 bar, S1 bar and S2 bar will tell you what type of machine cycle or what type of bus cycle is being taken place during the current bus cycle. The current bus cycle is of what type? So if S0 bar is 1, S1 bar is 0, S2 bar is 0, it means input output read bus cycle is being taken place, means microprocessor is accessing input output data for read purpose. Then if S2 bar is 0, S1 bar is 1 and S0 bar is 0, means input output write bus cycle is being taken place, means microprocessor is writing something to the input output data. If 0, 1, 1 is the status, means microprocessor is at halt state. If 1, 0, 0 is the status of S2 bar, S1 bar and S0 bar, means instruction is being fetched. Instruction is being fetched. Then if the status of S2 bar, S1 bar and S0 bar is 1, 0, 1, then memory read bus cycle is being executed. For memory write bus cycle, what will be the status? 1, 1, 0 will be the status of S2 bar, S1 bar and S0 bar. And if all the 3 are 1, means it is at inactive state. The bus cycle, the microprocessor is at inactive state. So this was all about the pin configuration of 8086 microprocessor. Next I am going to discuss about the bus cycle, and then we'll go for the addressing modes. I'm ending this class here. Thank you.